to convert between fractions and decimals and decimals and fractions. All right, so let's look at an example. So say we want 8 and 2/5, and we want to convert that to a fraction. This one we can actually do with mental math. And the reason we can do this with mental math is because it has a denominator of 5, so we can easily create an equivalent fraction that has a denominator of 10. So this 8 and 2/5 is equivalent to 8 and 4/10. And remembering that our place values are all based on powers of 10, the tenths place, the hundredths place, the thousandths place. If this is 8 and 4/10, that immediately tells us what the decimal is. So it's 8.4. But if we wanted to do it the longer way, we would do division. So we know the whole number part is going to be 8. We want to know what's the decimal part going to be. We would divide. So we would say 2/5 is equal to 2 divided by 5. And we would do that with long division like this. So we would say 5 divided into 2. 5 is larger than 2. So what do? Well, there's a property of decimals. So let's say we have a whole number such as, let's say 14. That 14 is equivalent to the decimal 14.0. We can add a 0 after a whole number and it does not change the value. We can actually add more zeros. We can add as many zeros as we want to after a whole number and it doesn't change the value, right? So this is 14.000000000. It's equal to 14. We can add as many zeros as we want after a whole number. It doesn't change the value. So coming back here, if we're doing 5 divided into 2, we can say 5 divided into 2.0. As above, so below. If we add a decimal point here, we add a decimal point at the top as well. So now let's divide. 5 into 2, 0. But 5 into 20 is 4. And then that's 20. 5 times 4 is 20. We subtract, we get 0. So again, we see that 8 and 2/5 is going to be equal to 8.4, right? Look at another example. Let's say we have 2/3. 2/3 is equal to 2 divided by 3. So that's going to be 3 divided into 2. 3 is larger than 2, so we make 2 a decimal. 2.0 at our decimal point here. 3 into 2, 0. 3 into 20, 6. 6 times 3 is 18. We subtract that, we get 2. We annex another 0, and then we can bring it down. So now 3 into 20 again, that's 6 again. 6 times 3 is 18. Now wait a minute. We can see a pattern forming here. If I keep doing this, I'm going to keep annexing zeros. I'm going to keep getting 20. 3 going to 20 is going to keep going 6 times. So this is how we create our repeating decimals. So 2/3 is equal to 0.6 repeating. All right, we would, doing the division, we would just continue to get 6s all the way across the board. So that's how 2/3 is equal to 0.6 repeating. Let's look at another example. Let's say we have 5/8. We want to know what is that equal to as a decimal. Well, 5/8 is 5 divided by 8. So we can do the long division. That's 8 divided into 5. 8 is larger than 5, so we change 5 into a decimal. Bring our decimal point to the top. 8 into 5, 0 times. 8 into 50, 6 times. 8 times 6 is 48. We subtract, we get 2, too small, annex another 0. Bring that 0 down. 8 into 20 is going to be twice. 2 times 8 is 16. We subtract, we get a 4. We annex another 0. We bring it down. 4 becomes a 40. 8 into 40 is 5 times 40. 8 times 5 is 40. Subtract the 40s, we get 0. So we see that 5/8 is equal to 0.625. To convert decimals into fractions, we take advantage of our knowledge of place value. So for example, if we have 0.125, we know that this is 125 hundredths. So based on that, we can write the fraction. 125, not 125 hundredths, but rather 125 thousandths, right? This is tenths, hundredths, thousandths. So 0.125 is 125 thousandths. So that's 125 over 1,000. Then we can simplify. So common factor here, the one that jumps out to me is 25. So we can divide both our numerator and the denominator by 25 to simplify. So 125 divided by 25 is going to be 5. And then 1,000 divided by 25. Well, I know that 25 goes into 100 4 times, and 100 goes into 1,000 10 times. So 10 times 4 gives me 40. Right? So 25, so 100, so 1,000 divided by 25 is 40. We can simplify it even further because there's a common factor between 5 and 40, and that common factor is 5. So we can divide both top and bottom, numerator and denominator, by 5. So 5 divided by 5 is 1. 40 divided by 5 is 8. So 0.125 is equal to 1/8. Okay, let's look at another example. Let's say we have the decimal. Let's say we have 0.9055. Well, based on place value, we know we're at the tenths, hundredths, thousandths, we're at the 10,000th place. So we know we're over a denominator of 10,000. So this is 9,055 10,000ths. 9,055 10,000ths. And then from here, what we have to do is we have to simplify. All right, so we can do the long division there just to get our practice. So 5 into 9,055 divided out by hand. So 5 into 9, that's going to be once. And that will be 5. We subtract that, we get a 4. Bring down that 0. 5 into 40, that's going to be 8. 5 times 8 is 40. Subtract, get 0. Bring down the 5. 5 into 5 is 1. It's going to be 5. We subtract, we get a 0, and we bring down the final 5. And again, 5 into 5 is 1. So 9,055 divided by 5 is 1,811. And then we can do 10,000 divided by 5 because we know that 5 goes into 10 twice. And then we have the 3 zeros, so we know it's going to be 2,000. Right? So 2,000 times 5 will give us 10,000. All right? And I believe that this is our answer. This is it in simplest form. So 0.9055 is 9,055 10,000ths. We simplify the fraction. We get 1,811 2,000ths. All right, final one. Let's say we had the decimal that looks like this. Let's say we have 5.315 repeating. So again, remember this repeating sign means that all these digits are repeating. So this is equivalent to 5.315, 315, 315, 315, 315, and so on and so forth. This is a repeating decimal. So the rule with repeating decimals, to turn these into fractions, we put the repeating digits in the numerator. So we know that the whole number part is going to be 5. We know it's going to be a mixed number. We put the repeating digits in the numerator, and the denominator is going to be the same number of 9s as the number of digits in the numerator. So we have 3 digits in the numerator, so this will be over 999. All right, so this is our magic 9. So again, put stuff over 9s is how we make these repeating fractions. Then from here, all we have to do is, again, simplify. So we can divide, let's see, what can we divide by? Okay, we can use our divisibility rules to determine that 315 is divisible by 9. So if you remember, the rule for 9 is if the sum of the digits is divisible by 9, then the number is divisible by 9. So if you do 3 plus 1 is 4, 4 plus 5 is 9. So 9 is divisible by 9, so 315 is divisible by 9. So let's divide it out and see what we get. So 9 going into 315. So 9 into 31 is going to be 3 times. All right, so 9 times 3 is 27. And 31 minus 27 is 4. And then 9 into 45, that's going to be 5. And so that's 45. All right, so we get that this is equivalent to 5 and 35, and then we have to do 999 divided by 9, which is mental math. We know that's just going to be 111. And that's our final answer here. So 5 0.315 repeating is equal to 5 and 35 111ths. So again, the rule with 9 is that any digit over 9, any fraction that has a denominator of 9, if it's the same number of digits, is just the decimal is equal to that repeating. So 8/9 is 0.8 repeating. Okay, 32/99 is equal to 0.32 repeating. Feel free to practice this at home on your calculator in your free time on a Friday night. This is really cool stuff, right? And again, it's the digits that matter. The digits have to match up. So let's say we have 2,071 over 9,999. Can you guess what it will be? Well, you are exactly right. You're so smart. It's going to be 0.2071 repeating. All right, so that is how we convert fractions into decimals and decimals back into fractions.